Hey guys, I wanted to go over a couple of the answers on the sex-linked traits homework just to make sure that you understand exactly how to do this and to make sure that you are doing it right. So the first one right here, we can see, let me turn on my pen. We can see that you would get a 50% chance if a man and a woman have an offspring, there's a 50% chance that it'll be a male and a 50% chance that it'll be a female. And this is why, because males have an X or a Y to give, and females have two X's to give. And so, what is the probability that their fifth child will be a girl? 1/2. In the sixth child, 1/2. In the seventh child, 1/2. They're all 1/2. Doesn't matter how many you have a 1/2 chance of it being a female or a male. So these are the genotypes for a woman who does not have hemophilia. So capital H, because not having the disease is dominant. And so therefore a woman with hemophilia has little h, and a woman that is a carrier would be big H, little h, each on the X chromosome. A male who has hemophilia would be X, little h, Y. We know that we cannot put the H on the Y chromosome because the Y chromosome does not carry that gene. Remember that the Y chromosome is much smaller and it's missing many of the genes that are on the X chromosome. So therefore, write the genotype of the man who does not have hemophilia. On his X chromosome is a healthy gene, and the Y, there isn't the gene present. And so here, a woman who is heterozygous for hemophilia, so big H, little h, marries a normal man. X, big H. What are the possible phenotypes of their children? So here we have a normal female. We have a normal male. So let me grab my pen, blue, and we're going to draw. And I'm going to put a little check here, normal female. We have a normal male. We have a carrier female, so she's normal. And a male with I put without. Let's put a female. I mixed this up. So we have a male with hemophilia. So right here. And if we were to do the next one, a woman who is a carrier for hemophilia, big H, little h, marries a man who with hemophilia. So little h on the X chromosome, no H on the Y chromosome. So what is the chances that could any of their children have hemophilia? So this female does not, she's a carrier. This male does not. This female does, and this male does. So they can produce a normal female, they can produce a normal male, and they can produce a female with the disease and a male with the disease. So it would be if so, would any of the children be male or female with the disease? So we would have both a male or a female. Let's go to our next page. I need to turn off my pen. Here we go. And I just wanted to do a couple of the color blindness to make sure that you understand what's going on. So here we are. So once again, the rules are the same for writing out the genotypes. A woman who is not colorblind, big B, big B. A woman who is colorblind, little b. A heterozygous or a carrier would be big B, little b. The genotype of a man who is colorblind, little b on the X chromosome, and the genotype of a man who is not colorblind would be big B on the Y chromosome. And so if a colorblind man marries, so we have a colorblind man here, marries a female who is a carrier or heterozygous, so big B, little b, what is the probability that they will have a child who is colorblind? So this female child is a carrier. This male child has color blindness. This female child has color blindness. And this male child has color blindness. Actually, I take that back. My picture's a little bit messy. This X right here has a big B and from the mom. And so this male does not have color blindness. Neither does this female. But this female does, and this male does. And so therefore, we have a 50% chance of the offspring having a color blindness trait. Okay, I hope that helps. And if you have any questions, let me know.